先来介绍一下下午 R2第二场演讲的讲者是印度的工程师啊，他名字叫做 Tasdik Rahman。他刚从6月的时候刚从印度 SRM 大学资工系毕业，也就是应届毕业生。那在印度的 Python 社群非常的活跃，就是他说他昨天在讲者晚宴的时候跟我们说，他印度到处飞。那我还没有遇过工程师台湾到处飞参加Python 的 meetup，这样就是他是非常有趣的人。对，然后他也是看到台湾就是6月他一毕业的时候有PyCon 的时候就立刻就买票，然后就来，然后就投稿，然后我就觉得非常有趣，因为他想要知道亚洲 Python 的社群是现在发展到什么程度这样。然后今天要为我们带来的主题是 Python 在 import 不同的 style。那 I will introduce a little bit in English so I can see. Tasdik Rahman is a 21-year-old engineer from India. Tasdik just graduated from SRM University with a degree in computer science. He is an active member at PyCon India, a popular event that gathers 1,500 Python programmers across India. And the title of his speech today is Diving Deep on How Imports Work in Python. Please join me in welcoming Tasdik. 掌声欢迎讲者，谢谢。
Hello. A very good afternoon to you guys. I'm Tasdik. So the title of my talk would be Diving Deep on How Imports Work in Python. And thank you so much for coming by to attend my talk. Yeah? It's not audible? Is it audible? Yeah, okay. So let's start. Before getting into this talk, let me tell you the motivations behind why I'm trying to demystify a little bit of how imports work, right? When you first started programming, the first thing which you would be doing is writing something into your interpreter or writing a script, and you would be unconsciously or subconsciously importing modules which were built in the Python standard library. But did you care to think about before importing that OS module of how it actually works in the inside, or what exactly is Python doing to find the OS module inside? At least I didn't, right? It just worked. So as I said, right, in the start, you would be writing things in the interpreter when writing things. Like, let's say you wanted to find the sum of two numbers, you define a function, you return it, you return the result of it, right? You just write down the functions or the variables which you wanted to define, and it just executes them line by line. But let's say you want to save that for later use. Let's say you want to save that script which you just wrote in your interpreter for use in something different, right? So you save it as a module. So the .py file which you save is nothing but a module. So everything you write inside it, every .py file would be a module. Now there would be some terminology while I would be explaining, which I would be explaining like in the following slides. So what actually happens when you do an import OS? So the first thing which happens is there is something called as a dunder import method, which would be a low-level a Python implementation. So if you wanted to check out the CPython implementation, it's there inside the GitHub repo. So it's just import.c file. And the loader function, what it does is, as the name suggests, it loads the module. Like let's say you do an import OS. So what it does is, if you do an os.dunder loader, it just returns the function object which loaded the module at first. And the finder would just be something which finds the module for you. Now, how does Python search for the path or the module in its path? So there is something called as sys.path, which takes into, so it's just a list which contains strings. The strings would be something which would be having system paths depending on your system which you're using. let's say if I'm on my Mac, if I do a sys.path and print it, so you can see a list of strings, which would these would be the locations where Python would be trying to find the modules which I'm trying to import. Now, as you can see, the first element of sys.path, the list, is empty. Now, what does that mean? Now when you invoke the interpreter, or when you are trying to access the sys.path list inside an interpreter, you are doing it interactively. So it tells Python to search for modules inside that current directory. Now let's say if I do it inside a module, right? Let's say if I have a module named foo.py, and inside that I run those two statements, import sys and print sys.path. So the first element inside that list would be the path where foo.py resides, right? Now, to make imports faster, you must have come across dunder PyCache directory. So what it holds is, let's say if I have imported a module called spam.py in the current working directory, so there would be a folder inside in the same working directory which is named as PyCache, and inside that you would be having a .pyc file. So this file is used, so it's basically bytecode. So what it does is, like instead of like reloading the whole module, what it does is it just looks up this and then imports it. So it's faster. Also, it's platform independent, and let's say you modified the source foo.py, and there would be a regular lookup about the modification which is happening inside, so that you don't have a stale import. Now, what actually happens when you do a import foo? As I said, it's like I explained the process of how Python goes on finding it inside the sys.path. Now, also the variables, which are the strings which you saw inside sys.path list, it is taken from an environment variable called Python path, which would be something just similar as how you define environment variables inside your system, right? Now, if a module is retrieved successfully, what happens is, let's say I do an import foo, so what happens is that module is bound to the namespace, the current namespace, so as to speak. All the methods, functions, and variables defined inside foo would be accessible by the dot notation. Let's say foo contains a function called sum. So I can access it after the first statement doing a foo.sum. Similar for the other statements. So what is different from the first import and this import? You can see so there's this rule. There's this rule where foo.bar should always be the foo should always be a package, and bar can be a submodule, and then bas can be a variable or a function. So these are different styles of importing functions or modules, so as to speak. Yeah. So I just explained. So there's this another style which you must have seen while reading other source code, or you might have tried this out on your own. So what this does is, inside this module called foo or package called foo, it tries to import everything under the namespace. But it's not. Personally speaking, I would, from what I have seen, what it does is, like, there are disadvantages to it. The disadvantages being that it pollutes the whole namespace. Let's say you have a function called sum defined inside the module foo. Now, what it does is, it collides with the internal built-in implementation of sum. Now, you don't know exactly which function is getting called when you do a sum. So this being one of the problems, and as well as it pollutes the whole namespace, right? Now, moving forward to packages, like, what exactly is a package? So to understand that, as I said, like if you wrote something in the interpreter, there were a list of definitions which you did. So in order to consolidate them in a single file, you made a module. Now let's say you have a lot of functions, right? A module does a particular task, another module does a particular task. Each module is designated a specific task for itself. Now let's say you want to structure it, right? You want to structure it. How do you do that? So you do that using packages. You don't want the whole list of modules to be splattered around in a single directory. It's not clean, as well as it's unmodular, so as to speak. Now, the advantages being obviously that the code becomes more readable. If you package your modules inside packages, it just becomes more reusable, so as to speak. So if you are refactoring your code sometime later, maybe in the next 1 or 2 months, it becomes very easy for you to read specific parts of your code and refactor it. Now, I love cars, right? So as for this package example, I would be using the package called car. So as you can see, car would be the top level package, and you have sub-modules, sub-packages inside car, which would be engine, transmission, and infotainment. Now, as I said, like I have divided the modules based according to the functions which they are trying to do for the car package, right? Now you can see there are various other sub-modules inside the sub-package engine, transmission, and infotainment respectively. So these are the modules which do the task which they are required to do inside that sub-package, right? Now you would have seen the dunderinit method inside the sub-packages. What is the purpose of the dunderinit.py method? The purpose being it tells Python to say that the directory is a package and not something else. So let's say if I have written engine inside the directory engine, I have done I have made a .dunderinit method. So it says that engine is a package and not some ordinary folder, right? We will come to what is the use case for init in a while. Yeah. So now so coming to reusability, right, as I said, now how do I make imports for specific functions or modules or tasks, so as to speak? So let's say you wanted a function called spin defined inside the ref function. So these are one of the alternative methods which you can do so as to get that functionality out of your package. The first one would be you are referring to the whole package name, so as to speak, right? So it binds the whole package name, but you still have to give the whole package name to access the function or variable defined inside the submodule ref, right? The other method which I can do, so this is too verbose, as you can see. I have to write the whole package name. It might, so let's say if you have packages under packages, or let's say 6 packages, and you want to import something inside that, so it gets very verbose very quickly. So now what you can do is to overcome that. You can do the second import. So what that does is it goes inside the package car and the submodule engine, and then it tries to find the rev module. The ref keyword can be anything ranging from a submodule or a function name or a variable. It can be anything, but it's not the same case with the first one. The starting 3 words, which is car, engine, and rev, have to be a package. So rev.spin, you are trying to access it. You're trying to access the function itself. The third one is the simplest. Let's say you just want the spin function and you don't want the namespace bind it to your the function spin, bind it to your namespace. If you don't want that, you can go with the last one. So what it does is it just goes inside the package car, the submodule engine, and the submodule rev, and then it tries to find whatever spin is. It can be anything ranging from a function definition or a variable. Now let's say you wanted some functionality here. That would be like, let's say if you do import, coming back to this import statement, let's say you do this let's say you do a from car import from car dot engine import star. Now, what are the things that would be imported? Could you make a quick guess and keep it in the back of your mind? From car dot engine, you do an import star. What do you think would be getting imported? Right? Now here comes the dunderall method. So what you can do is to control what is getting imported. When you do a from car.engine import star, you can put this dunder method inside your dunderinit.py file. So when you do this, Python, so dunderall is a list where you specify the submodules which need to be imported when you do a from car.engine import star. So if I have the following, so as you can see from car.engine import star, so let's say if I am inside the file car.engine init.py, I have put dunderall temperature, fuel and coolant. So these are the modules which I want explicitly to be imported when I do a from car.engine import star. So this is something which the author of the module can do at the start of the file. So it becomes easier for the user to have all the required things in his namespace. But it becomes a problem when you have a growing number of modules inside your package and you are not updating it regularly. So this would be one of the use cases for dunderall. And this would also be so there are a lot of things which you can put inside dunderinit.py, this being one. The other things would be like, let's say you want to initialize a class object which you would be using when you are importing something, or as well as like defining variables, global variables. These are one of the things which you can put inside your dunderinit.py. Now, how do you do intra-package references? Like, let's say I have in this directory structure, let's say I have in this directory structure, let's say if I'm inside transmission package and then I'm inside forward.py. Now, if I wanted to use the module inside engine, which would be fuel.py, how do you do that? Now, a quick question for you guys: how many of you have like faced problems when importing packages in your projects? Didn't any of you have any problems while importing packages in your projects? Can I have a quick show of hands? Oh, that's less. The others might be lying, I would say. Yeah. At least I had a hard time figuring out how things worked when importing things. Right. So there would be random import. I would try hard coding relative imports, absolute imports inside different packages, but it didn't work at sometimes. I'll be coming back to that. Yeah. So how do you do intra-package imports? Like, let's say if I wanted inside my temperature submodule module, I would want the forward module imported. So what you can do is you can have an absolute import or a relative import. The first one you see is an absolute import, which explicitly says that in the package car there would be a sub package transmission from where you have to import the module forward, right? There are some disadvantages to this. The first being, let's say I renamed the package, the top level package, I mean to say the parent package being car. Now let's say I renamed it, right, to something different. Let's say I renamed it to a truck. Now what happens to the imports? It breaks. It breaks, and it breaks in the other places where you have put this, right? The second one which you see is a relative import. So the dot symbol which you are seeing is telling Python to go one directory above the current package level and look for the sub package called transmission. If it finds that, it again goes inside that sub package and tries to find the module or the function definition or the variable which is named as forward. If this is not found, it would raise an import error, as you would see reasonably quite often. Now Now, if you see that dot, you can do further levels of going to like packages above that. Like let's say if I wanted to go even one level beyond that, like let's say I wanted to go to the car package, right? The car package. So what I can do is I can do a from double dots transmission import forward, but it would obviously fail because there is nothing known to the Python namespace called forward in that directory structure. Now, relative imports give you the flexibility of like as I said, like it gives you the flexibility of like having the top level package not hard coded to your code. So in some ways, if you are restructuring your project, let's say your parent package is named version v1 for your software release, or you are like doing the structuring like that, so it gives you the flexibility of like moving around things. But in some ways, like let's say if you are so what happens is in the relative import, like if I'm doing a relative import inside a module, what it tries to look is inside there would be something known as a dundermain method, which would tell Python the name of the module. So let's say if you're running this inside a module, it would try to look one level up of the current module from where you are executing this script. So you have to take care of the fact that you are running it from the current directory. And let's say if you run this from the car module in different directories, this definitely won't work. But if you are sure that you are never going to rename your top level package named car or for any reason, I would suggest going with absolute imports. And as some PEP discussions which were happening in the Python mailing lists, there was one time when if you do an import foo, what it does is like let's say you have a file called spam.py, and inside that you are trying to do an import foo. So what it does is it tries to find inside the foo namespace inside the spam namespace the foo submodule. So it doesn't go exact. So this was back in Python 2.7, which was re-implemented and rewritten in Python 3. So what happened back then is if you tried to do that, so what it has something called a sys.modules, which has a dictionary storing all the imports which you have done till now. So if you again do an import, what it does is just goes and does a lookup in that dictionary and doesn't go and reload the file again from the file path. So these were some of the things which I would say, and yeah, if you have any questions, I would be happy to take them. Yeah.
Okay. Recently, I've encountered a problem that I'm in the current directory is in a like child folder, and I want to import a module from the parent folder. So how do I do that?
You said, if I got the question correct, you have a child module inside a parent package?
Yeah, so maybe you can go to the slides of your cars.
Sure. Yeah.
So for example, I'm currently in the engine folder, and in the ref.py, I want to import a module from the folder in the car.
Which one?
The car. Currently, you have like a car and engine and transmission in fundament, right?
Yeah.
So for example, if I have a foo.py in car.
Yeah.
And
in the parent directory? Yeah,
in the parent directory. And I want to import the foo.py in the ref.py in the engine directory.
So foo.py would be on the same like level as engine package? Is that what you're saying?
Yes.
So inside foo you want to import fuel.py?
Inside like engine ref.py, I want to import foo.py. And foo.py is in the car directory.
Alright. So you can do a relative import. So what you can do is like from you want to go one directory above, so you do a dot from dot you do an import foo.py. I think that should work. Or you
Actually,
can.
I've tried that, but it seems that it will raise the import error.
So as I said, you have to take care of the fact the dundermain method. So if you are doing that from a different directory structure, let's say you are inside the car package and then you are trying to invoke the method where you are trying to import foo.py, it probably would give an import error. So you have to take into consideration that you have to be inside the sub package engine when you are when you are running that script, which is trying to import foo.py from car package. Make sense? Or you can do an absolute import. That should definitely work.
Okay, thanks. I'll try that.
Yeah.
Any more questions? Yes, in the back.
Hi.
Yeah.
There are many scenarios and cases that I've faced before. In a single Python file, there are many functions, and I used to put all the imports on the top of the file, and there's a case that just one single function use several imports.
Yeah.
Okay, and if I'm going to refactor the function and put it into another Python file, I need to copy several sections of the code and put it in the other file,
Yeah.
which I think is not Pythonic and is not convenient. So my question is, do you prefer if in that case there only one single function that use several imports? Should you prefer put it in the top, as I've just said, or put it under the function itself?
I would say so. So if I got the question correct, you are saying you have a Python file where you have multiple imports at the start, and then you have a function where you are doing something with those imports. Or what?
In the file, most of the functions use common imports.
Oh yeah.
And
So
only
inside
one- yeah.
inside the function you have import statements.
Yes.
Okay.
So there are many, say, 10 lines of code shared the same import of the functions in that file.
Yeah.
So it makes sense to put all the imports on top section of the file, but there are single function that use several lines of imports.
Yeah. I get it. So I would say, so I didn't tell you, so I missed this point, I guess. So when you are importing a module, what happens is Python just runs it sequentially, line by line, right? So it's as similar as doing a Python module name.py, and it would just give you something at the end. So when you are doing an import, your module name, right, what happens is it runs the whole file sequentially. So you would be executing a whole lot of things which you might not be needing, as you are saying, right? So I would say like refactor the thing. If it's a large project, it might also take a lot of like time or memory, so as to speak. So if you are like breaking the imports down and functions down when you are trying to, so I would say if you have, so if I got it correct, like you have a function and then you have multiple imports inside that, right? So that I think that is the best thing to do in this scenario, because some imports might never be used till some point of time. So what it does is it's just wasting CPU cycles when it's trying to like run the whole import function from top to bottom. Make sense? Or I didn't.
Excuse me. My question is, as you just said, there are a function that's seldom used, but it exists for some reason. So if I want to refactor that function into, say, for example, a command.py file for refactoring, should I put the import functions? Sorry, I mean in the initial version of the file, I put all the imports at the top section.
Yeah.
But then if for any reason I want to refactor the function to another file, then it comes to a problem that I need to copy and paste the function code, function section, and I need to copy the import sections as well. Remove some lines, and then so that's inconvenient and buggy.
I see.
For a careless mistake.
So inside your command file, what you can do is that you can import the function itself. As I said, I think I got your question. If I'm not wrong, what you can do is like, so let's say your function would be rev here, right? Your function would be rev inside that, and what you are doing is you are writing a whole lot of code, and you are saying that you are pasting that rev again and again and in different places. So what you can do is like you can import the ref function inside your CLI file, if that makes sense. What do you think?
I think I should stop, and perhaps we can discuss
Yeah, we can
later.
take it offline. If I'm not understanding the question properly, I guess. Yeah.
还是可以待会再跟他请教这样。Any more questions？ 还有其他问题吗？有，好，请说。
Hello. If I'm in your root, let's start. Yeah. If I'm in music.py and I want to import from sibling directory like fuel.py.
Can you repeat?
Yeah. If I'm in music.py, I want to import from sibling directory like fuel.py.
Yeah.
Yeah. And instead of flow, say you need to system.path and add some paths into your file, and then you can do
System.path?
Yeah.
Yeah, you can definitely do some hacks in this. So system.path is accessible to the programmer when the script is being run. So what you can do is like so that is a hacky way of like including fuel.py. So what you can do is like put what was that your question?
My question is there any better method than use system.path.append blah blah blah?
Yeah, like that. Relative imports was there, right? So relatives or absolute imports was one of the cleaner methods of doing something instead of doing a sys.path.append where you are appending your fuel.py inside your music file. So like a relative or an absolute import would be a cleaner way of doing that, or accessing the fuel.py code inside your music.py code. So sys.path is not recommended. So hacking sys.path is not recommended because it gets dirty real quick from what I have seen in my personal experience. So I would definitely not suggest like appending your path files inside sys.path. So I think you are referring to this one. Appending your path file inside this, if I'm not wrong, right? Yeah, it definitely works if you're appending the fuel.py path inside your module music.path and then explicitly appending that using the sys.path directive. It should work, but it's not suggested, I would say. Okay, yeah, please.
What happens if I import a module multiple times? Does it check before they run through all the paths?
Inside the same module, are you saying? Like I'm doing the same import multiple times inside the same module?
Yes, for example, I have a function that is called multiple times, and in that function, I import OS.
Yeah.
And when I call this function the second time, would it import again?
No. So there's something called a sys.modules, as I just mentioned some time back. So what it does is, when I do an import.os, what it does is it goes to the sys.path and tries to find inside that directory where OS module is. It imports it. It makes an entry inside sys.modules dictionary.
I know. I just made an experiment.
Yeah.
I import OS, and I can access the OS module from sys.modules and OS, right?
Yeah.
Then I delete it.
Sys.modules del. Yeah.
Yes. Then I delete it.
Yes.
And then I invoke os.path.
Yeah.
It still works. So I think it's stored somewhere else. it stores in sysdad modules.
Yeah.
Yet it stores also in the globals.
Yeah, globals. Yeah,
Yes.
yes.
When
yes,
I
yes.
delete the globals, then it vanishes.
It vanishes,
for
yeah.
good. Yes. So my question is.
So these are just references, like the
Okay.
way. Yeah, these are just references. So in the CPython API, you would. So these are the Pythonic way of accessing what is there inside your namespace.
Yes.
So there. So yeah,
what you're talking is the OS module exists already in the memory. I'm just deleting.
You deleted the reference. Yes.
Okay.
Yes.
So the next time I import OS, it finds a reference and then it stops the importing process.
So the way the GC works in Python is it checks references, right, from top to bottom about the references of how many times a variable is being accessed.
Exactly.
Right? Yeah. If I stop referencing it, it just deletes it. The GC just deletes that.
The module reference.
Module reference. But there are multiple references being happening, which as you checked out when you did a del, and the del operator deleted, you deleted that dictionary entry itself from sys.modules. So what it did, so what Python saw is like it's not there, so I would just reload it again.
Okay.
Yeah.
Okay.
Yeah.
As soon as I don't hack it, it will work.
Yeah. So
Perfect.
even the next curious question would also be like, how do you do hot fixing in modules? Like, let's say I have a server which is running some Python code. I'm running that module for some time, but now I had made some modifications inside some function.
Yes.
Let's say I want to reload that, right?
Yes.
How do you do that? So there's something called as import lib, if I'm not wrong. So what you can do is you can reload the function itself at runtime. So what web frameworks like Django do is like you are in the debug mode. So if you are like changing some code, what it does, it reloads it in real time.
Hard reload. Yes.
Yeah, hard reload. Yeah.
Yes.
But it's I would say it's pretty risky. Of like you can lose quite a lot of data. Not quite a lot. I haven't done it in production, but I've heard, from what I've heard is like it's not suggested hot reloading.
Yeah.
Yeah.
Okay. Thank you for your answering. Thanks.
Yeah, not a problem.
好，那我们就掌声谢谢 Tasdik 带来的精彩的演讲。